Hello everyone, welcome to another video. This video is going to be for chapter 3 lesson 2, which is about angles formed by parallel lines and transversals. Now in the previous video we did learn about different kinds of angles and how they are formed, but in this lesson we are going to relate them. That is how the angles formed by parallel lines or transversals are related to each other. That's what we are going to be looking at. Now before we start, let's quickly revise the previous videos, previous lessons content. This is all what we learned. That is, if a pair of parallel lines or a pair of lines, not necessarily parallel, if a pair of lines have been intersected by a transversal line, then there are some angles formed. Some of them are interior and some of them are exterior. Rather, 4 are interior and 4 are exterior. The one with the red shaded part are the interior ones, the inside angles, and the one outside are exterior angles. Now, again, referring to the same figure, there are 4 different kinds of angles which we learned. That's angle 1 and 4. That's not given here, but then I think we did discuss about angle 1 and 4, the relationship between these kinds of angles with opposite to each other or in the shape of a V. So angle 1 and 4 are called as vertical angles where they touch their noses. So these kinds of angles are called as vertical angles. So angle 2 and 3 are also vertical angles. Similarly, in this next set of angles, which are the vertical angles, look at this V shape here, angle 5. So which is the vertical angle for angle 5? Angle 8. The same way, angle 6 and angle 7 are vertically opposite angles, or vertical angles we call them. The next is corresponding angles. Now corresponding angles are on the same side of the transversal. There are like, if there is a transversal, there is this side of the left side of the transversal and the right side of the transversal. So corresponding lines are on any one side, but they're on the same side. They're not on the opposite sides, they're on the same sides, but then they are alternated with each other. For example, if you would say angle 2, the corresponding angle for angle 2 is going to be angle 6. So angle 2 leave, that's alternate angle 4, then the next angle. So they're on the same side, but then one after the other, one leaving one after the other. So which is the corresponding angle for angle 3? So for angle 3, can I say angle 3, the corresponding angle for angle 3 is angle 6? No, because they're not on the same side. So angle 3 and angle 7 are corresponding angles. Angle 3, leave the next angle, then the next angle they both become the pair of corresponding angles. So the next set of angles which we learned was alternate interior angles. Alternate means alternative, and then interior means inside. So we are only talking about these angles here, these particular angles 3, 4, 5, and 6, and alternate means opposite, we could say. So angle 3 and 6 are alternate interior angles. Same way angle 4 and 5 are also alternate interior angles. Then the next is alternate exterior angles. So alternate means opposites. So we have 1, 2, 7, 8. Which are the two opposite angles? We have 1, 8. So they both make a pair of alternate exterior angles. 2 and 7, that's also exterior. So they both make up one angle because they're alternate. So alternate exterior angle. And the same other one is the same-sided interior angle. Rather, they are in the shape of a U. So from the word itself, you could find out that they are same-sided, but then they're talking about interior angles. So can we say angle 1 and 3 are alternate interior, same-sided interior angles? No, because angle 1 is exterior. It doesn't count as an interior angle. So angle 3 and 5 are the interior angles, and same-sided means it's in the same side of the transversal. So angle 3 and 5 are all same-sided interior angles. Same way, angle 4 and 6 are also same-sided interior angles. What's special about both of them? If you add both these angles, that must add up to 180 degrees. And so this is the speciality of them, the same-sided interior angles. When you add both of them up, they must add up to 180 degrees. Other than that, corresponding angles are equal, all alternate interior angles are equal, and all alternate exterior angles are equal. So let's see, in today's lesson, you have to learn something about theorems and postulates. Now, first to start with, it's a postulate. Now, you might wonder what's the difference between these two? Why are they both different? Anyhow, we are going to prove using both of them. But yes, there is a difference. What's in easy words, the difference is that postulate is something assumed without proof. And like it's self-evident, it's generally accepted. So it's considered to be something without a proof. And then theorem is not like that. Theorem is when we use mental thinking or we use considerations, we use reflections to prove something. So that's the difference between theorems and postulates. So in this lesson, you just have one postulate. What is the postulate? Now do listen to me carefully. Just try to concentrate a bit so that you can understand it easily. If two parallel lines are cut by a transversal, then the pairs of corresponding angles are congruent. So the postulate here says if there are two parallel lines, not any lines, they must be parallel. So these are two parallel lines. And if it is cut by transversal, then the pairs of corresponding angles, now which are the corresponding angles? This and this. The pairs of corresponding angles are congruent. Now you all know the meaning of congruent. Congruent means equal, right? So for example, if this angle was for 70 degrees, this corresponding angle is also going to be 70 degrees as well. So this is what the postulate says. The corresponding angles postulate says if a pair of parallel lines are cut by a transversal, then the corresponding angles are congruent or they are equal. Easy. Now let's look at what the theorems say. Now these are three theorems we have. Alternate interior angles theorem. Now because if you would have understood the postulate, then I think you will have an idea what these theorems say. Alternate interior angles theorem. So again, what they say, if two parallel lines, so let's take a set of parallel lines. These are pair of parallel lines. If they are cut by a transversal, then the pairs of alternate interior angles are congruent. So what they say, where are the alternate interior angles now? This one and this one are alternate interior angles because they're inside, right? And similarly, so let's name this as angle 1 and angle 2. These are the interior angles, angle 3 and angle 4. So which are the alternate interior angles? Angle 1 and angle 3 are alternate interior angles, right? Alternate opposite interior inside. So according to the theorem, angle 1 and 3 are equal. So if angle 1 was supposed to be 75 degrees, it's not 75, it's more than 100. So if angle 1 is say 120 degrees, then angle 3 is also going to be 120 degrees because they both are congruent. So this is what alternate interior angles theorem says. Angle 1 and angle 3 are congruent. Angle 2 and angle 4 are congruent. Same way, let's see what the alternate exterior angles say. Now, where are the exterior angles here? Exterior means outside. So this is angle 1, angle 2, angle 3 and angle 4. So these are the four exterior angles. Now we know already what are the pairs of exterior angles. Angle 1 and angle 3 are alternate exterior. Same way angle 2 and angle 4. According to the theorem, it says if two parallel lines are cut by a transversal, then the two pairs of alternate exterior angles are congruent. Again, the same thing. If this angle was 60 degrees, so which is the alternate exterior angle pair? Angle 1 and angle 3. So if angle 1 is equal to 60 degrees, angle 3 is also going to be 60 degrees as well. Same thing. So similarly, angle 2 and angle 4 are also going to be equal. Let's look at what the last theorem in this lesson says. It says same-sided interior angles theorem. So what are they saying about same-sided interior angles theorem? First, from this figure, let's name which are the same-sided interior angles. Interior means inside. So it has to be something to do with it. Same-sided means on the same side like that. So angle 1 and 2, let's name it as angle 1 and 2 and this side as 3 and 4. So angle 1 and 2 are a pair of same-sided interior angles. Same way angle 3 and 4. See in the shape of a U, or rather it's like the angles inside a bucket. There is a bucket and the two angles inside are called as the same-sided interior angles. So if two parallel lines are cut by a transversal, then the two pairs of same-sided interior angles are supplementary. Now what does this word supplementary means? Supplementary angles equal 180 degrees, or rather we could say they are angles on a straight line, because linear angles, linear means line, so the angles on a straight line are also supplementary because they must add up to 180 degrees. Now already we have discussed previously in the lesson that alternate the same sided interior angles must add up to 180 degrees. If you add up angle 1 and 2, that must give you 180 degrees. Same way, if you add angle 3 and 4, it should give you 180 degrees. Alright, now these are the three angle theorems we had, and also we learned about one of the postulates, that's about the corresponding angle postulates. Let's go ahead and check and do some questions. Now, you have to find each angle measure. So how are you going to find each angle measure? A quick review, right? All alternate interior angles are equal. All alternate exterior angles are equal. Let me quickly write it down here so all alternate interior angles are equal. Do write it down somewhere in your book or somewhere which you always look at, in a place where you always your eye meets, so that whenever your eye meets, that will just automatically get recorded by your brain, right? The next one is all alternate exterior angles are equal, and then all corresponding angles are equal. Corresponding angles are equal. And finally, we have the same-sided interior angle. Same-sided interior angles add up to 180 degrees. Add up to 180 degrees. So these are the theorems and the postulates which we learned. Based on this, let's try to solve this question. So find each angle measure. They want you to find the angle measure. That's angle 1. So first, identify the two angles given to you. They have given this angle and this one. So what kind of angles are they? Are they alternate interior angles or are they alternate exterior angles? What kind of angles are they? They are corresponding angles. Sorry, they are same-sided interior angles, right? Because they're talking about the angles inside a U, or angles inside a bucket, like I explained previously. So they are same-sided interior angles. So what's the rule for same-sided interior angles? The theorem says same-sided interior angles add up to 180 degrees. So one of the angle is 133. How do you find the other angle? Simply, we can say measure of angle 1 is equal to 180 degrees minus 133 degrees. So that would give us 47 degrees. Now, if you want to further do it in step-by-step format, that's perfectly fine. We could say 133 degrees plus the measure of angle 1. We don't know how much is angle 1, so let's write it as angle 1 equals 180 degrees. Now you know what's to do next. So angle 1 is going to be equal to 180 degrees minus 133 degrees, which would again give you the same. So angle 1 is equal to 47 degrees. Now, what is the reason? Why are we saying 133 plus angle 1 equals 180 degrees? Because of the same-sided interior angles theorem. This is how you give proof that why did we do this. So for proof, we have to give the name of a theorem which we learned. So let's do question number 2. Here they are asking you for measure of angle 2. So this particular angle, and they have given us this angle. Now always first define what kind of angles are they. So they are corresponding angles. So we could say angle, the measure of angle 2 is equal to 119 degrees. And what's the proof we are going to give? Which theorem are we? Proof in the sense the theorem. So why are we saying angle 2 is equal to 119 degrees? Because of the corresponding angles theorem. Right? So this is how you reasons when asked, but rather than its theorem, it is a corresponding angles postulate, because that's not a theorem, it's a postulate which we believe in. So corresponding angles postulate. So the measure of angle 2 is 119 degrees. It's better always you give the reasons so that later on when you move on in the lessons, you will use these proofs, these theorems to prove. So moving on to the next question. They want you to find the measure of angle ABC. So angle ABC, which means the x degrees. That's what they want you to find. So they have given you x and they have given you this. What kind of angles are these? These are not alternate exterior angles. These are not alternate interior angles. They're not corresponding. So what kind of angles are these? They're not in any of those angles which we learned. But yes, we can use our knowledge and find out if this angle is 83 degrees, what is the measure of this angle? We know that these angles must add up to 180 degrees because they are supplementary angles. They're angles on a straight line. So 83 plus, let's name this as angle Y. You have to go a step forward sometimes to find the answers for these questions. So let's name this as angle Y. So first let's find the measure of angle Y. How do you find that? We can say 83 degrees plus Y equals 180 degrees. And why did we say that? Because of the supplementary angles theorem. Just I explained previously, supplementary angles means the two angles which must add up to 180 degrees. To find out the measure of angle Y, only then we can say that they're alternate interior angles, right? Without finding the angle Y, we cannot, of course, find this out. So to do that, we have to have the measure of angle Y. So let's find out angle Y. It's going to be 180 minus 83. That means that the measure of angle Y is going to be 97 degrees. Now that we have found angle Y to be 97 degrees, we could say angle X is also 97 degrees. How can we say that? Because of the alternate interior angles theorem. So we can say now angle ABC rather than X, let's say it as ABC, that's because that's what the question is about. So angle ABC is equal to angle Y. That's because of alternate interior angles theorem. I know it's a bit confusing and tricky, but yes, think a bit further. Do not stick only to the knowledge which the teacher gives or to the knowledge in the book. Go forward and think how you can solve this. Angle ABC is X, right? Which is 97 degrees. So the measure of angle ABC is 97 degrees. Now there is one more way you could do this. How can you do that? Instead of using this supplementary angle theorem, if this angle is 83 degrees, you know this angle as well is going to be 83 degrees because they are vertical angles and all vertical angles are equal. So if this angle is 83 degrees, now you could use the same-sided interior angles theorem to find out the value of angle X. It's the same. You have to subtract from 180 because all the same-sided interior angles must add up to 180 degrees. So the same thing whether you use the supplementary angles theorem or the same-sided interior angles theorem, your answer is going to be the same. You could either use this or that. Totally up to you. Now let's move on to question number 4. You have to find the measure of angle DEF. So this angle, and they have given us this angle, which means they are first establish the relationship. Find out what's the relationship between both these angles. They are alternate interior angles. So we could say angle DEF is equal to, now how do we name this angle? You can name it as, if there is no other way, so we have to name it as DEF. Okay, DEF, no, it won't be. Or rather than wasting our time on that, let's write 8x minus 34 degrees equals 5x plus 2 degrees. Now do not forget to give the reason why did you do this. Why did you say that 8x minus 34 equals 5x plus 2? Because they are alternate according to the alternate interior angles theorem. So according to the alternate interior angles theorem, all alternate interior angles are equal. Now let's solve this. This is an algebraic equation you need to solve. So bring all the variables to one side and move all the numbers to the other. So that would give you this. 8x minus 5x will give you 3x equals 36. X is going to be equal to 36 over 3 divided by 3. X is equal to 12. Now that's not it, because we have just found the value of x. Whenever you have equations like this, you have to first find out the value of x, then you will substitute that in the expression and find out. Now the next step is find the measure of angle DEF. So angle DEF is equal to 5x plus 2 degrees, which means replace the value of x with 12. 5 multiplied by 12 plus 2, so that's 60 plus 2, which is going to give you a 62 degrees. So the measure of angle DEF is going to be 62 degrees. Well, that was an easy one, but a bit longer because lengthier, because you have to find the value of x first and then you have to substitute the value of x and then write the answer. Always remember, whenever you get such equations, you have to first find the value of x or whichever variable is there. Only then you can proceed on with the next part of the question. So this question here, now this is called a two-column proof. Now what is a proof? Proof is something which they will give us a situation and also they will give us what we need to prove. So we have to use all the theorems which we learned, whichever is suitable. Not that we are going to use all of them. You have to use whichever is suitable theorem according to the question to prove what they want from you, right? So let's start here. For example, what they asked is complete the two-column proof to show the same-sided. Okay, they are saying same-sided. Now to make it easier, that's because the first question for you, they have given you this theorem which you have to use. Same-sided exterior angles are supplementary. So you have to show the same-sided exterior angles are supplementary. They have given us P and Q is parallel. So this is the given information. We need to prove angle 1 and angle 3 equals 180 degrees. We have to go step by step. We cannot at once skip many steps and say angle 1 plus angle 3 equals 180. We need to show step by step why is it equal to 180. Always start with the given information. They have given us P is parallel to Q. So we write the reason as given because they have given us this information. Now, what is the result of P being parallel to Q? See this reason, they gave us a linear pair theorem. From the figure, try to find out which is a pair of linear pair theorem. Which are the two angles which make up the linear pair theorem. Linear pair theorem means two angles on a straight line which must add up to 180 degrees. So let me draw it here and show you how linear pairs look like. Linear pair angles, they look like this. So similar angle, where can we find in this figure? It's angle 2 and 3, right? So linear pair, according to the linear pair theorem, we can say angle 2 plus angle 3 equals 180 degrees. This is the linear pair theorem. The angles must add up to 180 degrees. Okay, let's move on. Now the next statement they have given us is angle 1 is congruent to angle 2. Is that right? Yes, it is. But what's the reason we are going to give? Why is angle 1 equal to angle 2, congruent to angle 2? What kind of angles are they? They are corresponding angles. So because they are corresponding angles, so we say this is corresponding angles postulate. For corresponding angles, it's a postulate, not a theorem. So according to the corresponding angles postulate, we say angle 1 is corresponding to angle 2. Now the next reason given for us is definition of congruent segments. So which are the two congruent angles here? Again, congruent angles mean the equal ones, right? So which is equal? Angle 1 and 2 are equal. So we say angle 1 is equal to angle 2. That's what they want, which is the definition of congruent angles, these two congruent angles. Now finally we write what is in the statement side. We are going to write what is the proof. What are we going to prove? We have to prove that the measure of angle 1, that's the measure of angle 1 plus the measure of angle 3 is equal to 180 degrees. Now, how do we know that they both are equal to 180 degrees? We know if angle 1 is equal to angle 2, that means the remaining part is going to be for angle 3. If Now let me explain it in numbers for you. If this angle was 120 degrees, how much is this angle going to be? It's going to be 120 as well. How much is this angle going to measure? Now angle 2 plus angle 3, we said it's 180. So if angle 2 plus angle 3 is 180, to find the remaining angle, we have to subtract. So angle 3 automatically becomes 180 minus 120, which is 60 degrees. Now can we prove that angle 1, that's 120 degrees, plus angle 3, which is 60 degrees, equal to 180 degrees? Yes, we did. So we just substituted. That's all we did. We didn't do anything else. We just substituted angle 1 with the numbers, required numbers. So we get the reason as substitution. That's all. Yes, it's a bit confusing, but then try to practice some more questions so that it's an easy thing, but then you have to think a bit deep. That's what is required here. We have to see what is connected with what and what is the information they have given. Because of that information, what is the result? So these are the steps we need to prove. So let's move on to the next question. Now again, this question might look something new to you because you have not yet taken solutions of systems, right? Now these are systems where you have to use some special methods to solve. Well, we didn't take any such lesson, but if you still want extra information, which this lesson you will learn in algebra later on, if you want some extra information, you can watch the video forward and then you can get this how to do it. So here the question says the figure shows sandy beaches windsurfing across several waves. For this exercise, think of Sandy's wake as a line. So this is Sandy's wake, this one. Angle 1, that's this angle, is 2x plus 2y, and angle 2 is equal to 2x plus y. So this is 2x plus 2y and this is 2x plus y. You have to find the value of x and y, and they have given us this angle to be 70 degrees. So which angle can we relate to this? We can relate these, angle 2 and angle 70. So first let's write down angle 2 is equal to 70 degrees. That's because they are corresponding angles. Okay, now first let me write an equation using this. So what's the measure of angle 2? Angle 2 is 2x plus y. So I'm going to replace angle 2 this way, okay? So this is 2x plus y equals 70 degrees. Now, if you notice, we cannot solve this equation because we do not have the value of x or y. We can solve an equation only if we have the value of any one variable. So this is when the special systems come. But still, I'll show you how to solve this. So this is one of the equations we have. Keep it aside. Let's name it as number 1. Now, the next equation we could get is, we can say angle 1 plus angle 2 is equal to 180 degrees, right? Angle 1 plus angle 2 is equal to 180 degrees. And why did we say that? Just because they are same-sided interior angles. Same-sided interior angles. So let's replace. Let's substitute the values here. What's the measure of angle 1? It's 2x plus 2y. And what's the measure of angle 2? It's 2x plus y equals 180. So first let's simplify this because there are many x's and y's. So 2x plus 2x would give you a 4x. 2y plus y will give you a 3y. So this is the next equation which we have. Here we got one equation and this is going to be our second equation. Let me write it down here and show you how to solve these systems. These are called systems of equations. So 2x plus y equals 70 and 4x plus 3y equals 180 degrees. Now we have two equations which we are going to solve. Solving these are super easy. We just need to see whether we can find out a way to make both any of them equal. Either make this 2x equal to 4x or make the y equal to 3y. We can choose either methods. So if you want to change the 2x to 4x, we have to multiply the whole equation by 2. If you want to change the y to 3y, we are going to multiply by 3. So let's do it by 3, but then we are going to do the opposite. We're going to multiply that with a negative 3 because only then we can cancel out the variables. So let's multiply this by a negative 3. Even if you're changing this to a 4, you have to multiply by negative 2. So if you would multiply this, the new equation you're going to get is negative 6x negative 3y equals negative 210. The other equation remains the same. Now that we have two 3y's same, but then one is negative, one is positive, we could simply cross that out. What's left for us? The one which is left for us is negative 6 plus 4. That would give you a negative 2x, which is equal to a negative 210 minus 180 would give you a 30. Now x is going to be equal to, we can cancel these two negatives because two sides we do not need. Now we have found the value of x. So the value of x is going to be 15. How are you going to find the value of y? Choose any one equation, either this or this one, substitute the value of x and find out what's the answer. I think this looks more easier than 180, so let me choose equation number 1. So first one is 2x plus y equals 70. We got the value of x as 15 plus y equals 70. So 30 equals 30 plus y equals 70. Y is equal to 70 minus 30. Y is equal to 40. And bingo, you've got your answer. Well, I know you have not learned anything like this, but it's always better to learn something new rather than not learning anything. Even if you understood some things of this, it's always knowledgeable for you. That's how you learn new things, right? Hopefully all your answers are right. Comment and let me know how many of you have got the correct answers. So till we meet again, all what I would say is keep practicing.